Hey everyone, and a really warm welcome on behalf of Forge College. All right, let's dive right into this explainer. If you were with us for our previous lesson, declaring and emitting events, you know exactly how to broadcast activity to the blockchain. You use the emit keyword to basically shout out to the world, hey, something important just happened. But, here's the catch. Shouting into the void is really only useful if someone is actually listening and can make sense of all that noise. So today, we're focusing on indexing and filtering events. We're going to learn how to take all those emitted logs and pinpoint the exact ones we care about, all without melting your computer's processor in the process.
So here's the ultimate problem we face as developers. Think about this for a second. How do you actually find one specific event in a sea of millions of blocks? I like to think of this as our detective's blueprint. Imagine the Ethereum virtual machine is this massive, sprawling library that gets thousands of new pages shoved into it every few seconds. If you're looking for one specific transaction and you don't have an index, finding that clue is a sweaty, agonizing nightmare for your node. It would literally have to scan every single page of every single book. We need a much more targeted search tool.
Here's our roadmap for today. 1. The filtering challenge. 2. Index parameters. 3. The filter script. 4. The OR logic trick. 5. Tricky edge cases. And 6. Live listening.
Section 1. The filtering challenge, finding the needle. All right, out of the box, nodes rely on these things called Bloom filters. Basically, a Bloom filter is a probabilistic data structure. It allows an Ethereum node to look at a block and confidently say, hey, there's a really high probability your log is in here, or I'm 100% certain it is not in here, which is great for incredibly fast existence checks. But it totally lacks the precision for an exact match. It essentially tells you which haystack to look in, but refuses to just hand you the needle. For that, we have to design our events better from the ground up.
When you emit an event, the information can be stored in one of two ways. Over on the left side, we have the standard data payload. Think of this as bulk storage. It's cheap, sure, but it's completely unsearchable off-chain unless you unpack absolutely everything. On the right side, we have indexed topics. By simply adding the word indexed to an event parameter in your Solidity code, it moves from that slow lane right into a fast lane indexing system. It acts exactly like the Dewey Decimal System in a library, neatly categorized and lightning fast to search.
Section 2. Indexed parameters, mapping topics.
3. That is the magic number. You are strictly limited to a maximum of 3 index parameters per event, no exceptions. That's an unbending engineering constraint built right into the EVM itself, mostly to stop developers from endlessly indexing every little thing and driving up gas costs. It forces you to be a smart designer. You have to look at your event and ask yourself, okay, what are the 3 absolutely most critical data points my off-chain app will actually need to search for?
Let's break down exactly how those 3 slots are assigned. The EVM creates an array of topics, but take a look at how the very first slot, topic 0, is automatically hogged by the event signature itself. It contains the Ketchak256 hash of the event's name and its parameter types. And that's actually how the node knows which event just occurred in the first place. So this leaves us with exactly 3 remaining slots for our actual data, topic 1, topic 2, and topic 3. If you index a from address, a to address, and a token ID, they slot perfectly into 1, 2, and 3, padded out to exactly 32 bytes each. It's a beautiful, completely predictable mechanical mapping.
Section 3. Filter script, building with Node.js.
Okay, let's look at the imperative steps to actually build our search engine script. Step 1. You initialize your provider, something like Ethereum.js, and set up your ABI interface so the script actually understands your contract. Step 2. Use that interface to compute the topic 0 signature hash, which totally avoids any manual typo disasters. Step 3. Construct your topics array based on what you want to search for, making sure everything has that proper 32-byte padding. And finally, step 4, map your inputs to the JSON-RPC filter object and call eth_getLogs. Boom! You just ask the node to fetch exactly what you want and absolutely nothing else.
Section 4. The OR logic trick, multiple specific clues.
Let's map out our filtering intent here because this is where it gets really cool. Say you just want to match a specific from address. Your array is simply topic 0 followed by topic 1. Super easy. But what if you want to find transactions that went to either wallet A or wallet B? Well, Ethereum's JSON-RPC actually allows you to place a nested array inside a topic position. So for our to address in slot 2, we can just pass an array of topic 2A and topic 2B.
It acts as a built-in OR condition. And check this out. If you want to search by the to address in topic 2, but you couldn't care less about the from address in topic 1, you must put a null in the topic 1 slot to maintain the structural order. It essentially tells the node, hey, skip parameter 1 and match either of these items for parameter 2. It is an incredibly powerful trick.
Section 5. Tricky edge cases. Handling errors.
Now, if your script is just coming up totally empty, you'll want to check these common traps. First, normalize your addresses. A lowercase a versus an uppercase A and a hex address will completely ruin a strict match. Second, ensure you hex pad your values to exactly 32 bytes. Third, gracefully handle empty result arrays. Please don't let your script dramatically crash just because nobody traded a token in the last 100 blocks. And finally, beware the lazy, uncooperative suspects. Anonymous events. In Solidity, if you declare an event as anonymous, it simply refuses to leave a signature in topic 0. Sure, it saves a tiny bit of gas, but the whole topic array shifts left, meaning you literally can't search by the event name anymore. Don't let anonymous events break your indexing logic.
Section 6. Live listening. Preparing architecture. All right, here is a massive takeaway I really want you to internalize. That mapping is the reliable contract between on-chain logs and off-chain filters. The script we just outlined together, it isn't just a toy. It validates your entire Solidity event design. If you can't easily query your data using this logic off-chain, then your smart contract events are designed poorly, period. This exact filtering logic serves as the rock-solid core for any off-chain processing architecture you will ever build.
Okay, let's rapidly lock in the absolute core rules we just covered. 1. Index parameters jump out of the bulky data payload and straight into fast, searchable topic slots. 2. Topic 0 is almost always reserved for the event signature hash. 3. You have a strict maximum of 3 index parameters, so choose them wisely. And 4. Use nested arrays for OR logic and use null values as placeholders when you need to skip parameters. Before we wrap up, I want to leave you with a bit of a provocative thought to ponder. If you now have the tools to accurately filter the entirety of blockchain history in mere seconds, what kind of live trap can you set for the very next block that gets mined? How do you react to things in real time? Well, that is exactly what we are going to cover in our next lesson, Listening to Events Off-Chain. Thank you so much for joining me on this explainer. To continue your Web3 journey, run these scripts yourself, and dive way deeper into this topic, please visit forge.college. We've got some incredible resources waiting for you there. Keep building, keep learning, and I'll see you in the next one.